All right, we're doing limits at infinity with quotients, and we have square roots involved. I'm not sure if this is any different. I'm not seeing anything that's different here. So basically, we're looking at the leading or the biggest exponent, the leading term, I guess it would be called. So I'm not going to worry about the -3 or the +3 here. Those don't play any part as we go into infinity. And it looks like we're still in positive infinity here. So this basically turns into the square root of 16x to the 4th over 2x squared. The top would simplify into 4x squared over 2x squared. And as we go to infinity, these would reduce out. And we'd have 4 over 2. Final answer 2 is what I got. Okay, so nothing different here that I'm seeing. Just don't let the square root kind of fool you. You're just applying it to the leading term. Okay, so same kind of problem it looks like. What takes over as we go to infinity is just the 4x squared under the square root sign. And we have a 4x on the bottom. That would be the leading term or variable on the bottom. And this would basically turn into, don't forget, you may need this at some point, but a square root is the same thing as a 1/2 power for x. 1/2 is a multiply, an exponent to an exponent. So this turns into 4 to the 1/2 x 2 over 2, 1/2 times 2. Everything in that parenthesis has that exponent applied to it. We still have 4x on the bottom. 1/2 is the same thing as square root. 2x over 4x. As we go to infinity, the x's would reduce out. 2 over 4 turns into 1/2. So the structure is all the same. You focus on the leading terms and then just apply the square root only to that because that's what's in charge as it goes to infinity. 1/2. All right, let's see. What did I do wrong? 2. Oh, whoa. What did I do wrong? We've been getting a lot of these. Do you see it? Finally, it's hard to see on this computer, but that's the limit. So if that was positive infinity, that would have been okay. But this is the limit as x goes to, here we are, negative infinity. This is where you have to be careful about those square roots and exponents and all that. All right, so once again, what takes over is that leading term. So we're going to have the square root. I'm not going to do the exponential representation of a square root on this one. And we got 4x on the bottom. All right, so negative infinity, you got to be careful because that means there's that negative sign floating around, kind of dealing with itself. But as we go bigger and bigger, this negative 3x is not going to play any part. This 5 is not going to play any part. So basically, this is all that takes over. And we're thinking about a negative infinity here. So as we go to negative infinity, this will always be positive. That's the key. X squared will always be positive. And the 4 will kind of just pair up with the square root. The bottom, though, negative infinity means this is negative, always negative. So I got basically like a negative, I'll just do 4x. And this is always positive on the top. So that would be 2x. So this is always positive, always positive on top. As we go to negative infinity, because that was originally squared. And then this is always negative. And so what does that mean if you have a positive over a negative always? That answer is going to be negative. So it's my 1/2. The answer is going to be the same, but you just got to be careful about your sign because of that negative infinity. Usually nothing will really change about the number. So the structure was all the same that I did for the last problem, but you got to consider what happens when a negative goes in. So you're looking for odd and even exponents. I'll just make that adjustment. How's that? Yes. So be careful, Sanders. Do I want to look at the answer? Let's see how they approach it with the negative infinity idea. Okay. So their numerator, let's divide by square. Wow, they're going into like kind of a real detailed way of getting through this. Canceling, just basically what happens. All right, so I think they're doing more of like an algebraic approach. Me, I'm more of like a logic approach when I see these, thinking about odd and even exponents and going to negative infinity in this case. So let me just feel like I want to understand what they're kind of doing here. All right, so this is the original problem. This negative values. In the numerator, let's divide by negative square root of x squared. Negative square root of x squared, dividing by that. Yeah, I'm not really sure. Maybe I'd have to have Professor Khan teach me on this one. All right, I'm okay with my logic approach. All right, so let's see how my logic does on this one. Negative infinity again. Let's see how we do. All right, feel free to pause it, see if you have a shot. Also, for me, leading coefficient or term, 5x squared over square root. As we go to negative infinity, the biggest one's going to take over, x to the fourth. And we're plugging in negative infinity here again. So this is where you look at odd and even exponents. So on the top, this will always be what? Positive. So this is always positive. That's a plus sign, pretty ugly. This one is x to the fourth. So this one, what will that always be? This one will always be positive. And if we just reduce out and simplify our terms, I get square root of 16 is 4. Square root of x to the fourth is x squared. We have that matching variable and exponent, so that would reduce out. Always positive, 5 over 4. 5 divided by 4. Okay, so it seems like my logic style is working just fine. Positive infinity, just like we've talked about.